Hello and welcome to another video from Adams Academy, an expert online tutoring service for high school mathematics. We continue our revision for the 10th standard CBSE exam. In this video, we are going to look at areas related to circles. We are going to solve two problems that appeared in the 2015 question paper. Let's do the first one. The long and short hands of a clock are 6 cm and 4 cm long respectively. Find the sum of the distances traveled by the tips in 24 hours. This is a 3-mark question. Usually a clock has 3 hands. So in the question it talks only about the long and short hands of a clock, which means they are referring to the hour hand and the minute hand. The long hand is obviously the minute hand and the short hand is the hour hand. Now they have given the lengths of the two hands. So the long hand is 6 centimeters. And the short hand or the hour hand is 4 centimeters, right? You need to find the sum of the distances traveled by their tips in 24 hours. Now let's think about how many revolutions these hands will make in 24 hours. So if you look at the clock in the picture, you'll realize that in 1 hour the minute hand travels 360 degrees because it makes one full revolution. What about the hour hand? If the time changes from, let's say, 1 o'clock to 2 o'clock, the hour hand travels from 1 to 2, right? So in 1 hour, that's the distance traveled by the hour hand. So if you wait for 1 more hour, the hour hand goes from 2 to 3, right? So to go one full revolution, the hour hand will take 12 hours. So the minute hand takes 1 hour for a full revolution and the hour hand takes 12 hours for a full revolution, right? So how much is the distance traveled by the tips in 24 hours? 24 hours is 24 revolutions for the minute hand and 24 hours is 2 revolutions for the hour hand, because the hour hand takes 12 hours for one revolution. So in 24 hours it makes 2 revolutions. Now it's easy to find the sum of the distances traveled by the tips. Let's do these separately. The minute hand in 24 hours, it makes 24 revolutions. 24 revolutions is 24 into 2 pi r. That will be the distance traveled, because in one revolution it goes one full circle or one full circumference. That's 2 pi r. Right? So 24 times 2 pi r in this case is 6 centimeters. So this will work out to be 24 into 2 into pi is 3.14 and r is 6. That's 904.32 centimeters. For the hour hand, it makes 2 revolutions. That's 2 into 2 pi r. 2 into 2 into 3.14 into r in this case is 4. If you do that calculation, you will get 50.24. Now the question asks you to find the sum of the distances. So you need to add these two, 904.32 plus 50.24, which is 954.56 centimeters. Here's the next 3-mark question. In figure 3, ABCD is a trapezium with AB parallel to DC. AB is 18. Let's mark 18 here. DC is 32. And the distance between AB and DC is 14 centimeters. So when they say the distance between two lines, it means the perpendicular distance. So it's actually the height of this trapezium, right? So this height is 14. If arcs of equal radii 7 centimeter have been drawn with centers A, B, C and D, so all of these arcs at the 4 vertices have equal radii of 7 centimeters, right? So all this is 7. Find the area of the shaded region. So to find the area of the shaded region, obviously you have to find area of trapezium and subtract the area of these 4 sectors, right? For a trapezium, you know the formula to find the area of the trapezium. So if there's a trapezium with parallel sides A and B and a height of h, the area of the trapezium is half h into A plus B. This is a formula you have learned in smaller classes. So here it's going to be half into 14 into 18 plus 32. That's the area of the trapezium. From this you have to subtract the area of the sectors. You know that the area of a sector is theta by 360 into pi r square, right? Where theta is the central angle of the sector. Now we have 4 sectors here. Let's mark the angles as theta 1, theta 2, theta 3 and theta 4. So to find the areas of all the 4 sectors, you need to add theta 1 by 360 into pi r square plus theta 2 by 360 into pi r square plus theta 3 by 360 into pi r square plus theta 4 by 360 into pi r square. Note that r is the same in all these sectors. So this is 350 if you do the calculations, minus here you can take pi r square by 360 out as a common factor. Then you will have theta 1 plus theta 2 plus theta 3 plus theta 4. Now what is the sum of theta 1, theta 2, theta 3 and theta 4? These are the angles of a quadrilateral. And you know that the sum of all the angles of a quadrilateral is 360. So this is going to be 360. So this simplifies to 350 minus pi r square. So that's 350 minus, you can take pi as 22 by 7. R is 7. So that's 7 into 7. And if you do this calculation, you will get 196 centimeter square. Those were the questions from 2015. See you in another video where we will discuss question paper from another year. For more revision videos, please like our Facebook page and subscribe to our YouTube channel. Thanks for watching.